What's going on, Turd Nerds? Matt with Operator Mindset here, and in today's video we are going to be talking about MLSS, or Mixed Liquor Suspended Solids. If you don't know what that is, you're about to get familiar with it. And in this video we are actually going to be running a mixed liquor suspended solid test. So we are going to be weighing the solids, we're going to be running them through a filter, cooking them in the ovens behind me. We're going to show you how to get your MLSS at your plant, and we're also going to show you how to get the volatile content of that MLSS or MLVSS. So that's a lot of letters all put together. We're going to go over why it's important to have that information as an operator, especially if your process at your plant is activated sludge. Super important to know how to do this. This is also going to be very beneficial to anybody who is about to sit for their operator's exam, whether that's a class 3, class 2, class 1, or if you're even about to sit for your laboratory exam for wastewater. At the end of the video, we're going to put all the numbers up on the board. We're going to do the math. We're going to write it out. That way you can see physically what you're doing to get those numbers, and then how those numbers and the results you get from them correlate, and how that actually benefits you as the operator or lab analyst. Before we get into the video, make sure you subscribe to the channel, give this video a thumbs up, and guys, comment below if there's any processes you would like to see us do, whether that's wastewater laboratory or talk about as far as in the field and operations. Let us know in the comments. I'll do my best to answer any questions you have regarding this video or any others. And if there's any content y'all are looking forward to seeing or would like us to try to show you, put it in the comments. We'll get back with you and we'll do our best to make sure we can put it out there for you. We're thankful for all you guys that are tuning in. Let's go get us a sample and start the test. Alright, Turd Nerds, here we are on the counter. So this is what we're going to be starting out with. We have our vacuum flask here, and it's hooked up to our vacuum pump. So you will need one of those. Next, I have some filters, glass microfiber filters that we're going to be using for today's analysis. I also have a funnel which is going to attach here to the vacuum flask. Graduated cylinder which I'm going to use to pour up my sample in. When the time is right, we're going to go over all this in the moment of actually doing it. You will also need your sample, in case you were wondering. And then lastly, we're also going to need, for this part of the video, some tweezers. So the tweezers here are actually, if you can tell, have a flat tip. I'm going to try to make sure. So they are not pointed, they are flat. That's going to come into play whenever we're actually removing the filter out of the funnel. It's going to have some weight to it there, and if they're sharp tweezers, they're liable to rip your filter and cause some issues getting out. So just having a flat pair of those is going to help you greatly. So let's change direction of that camera and let's get started on the test. Alright, Turd Nerds, we're over here at our balance. Your analytical balance is a very important part of this process. You have to actually weigh your filter before you start the whole thing, so you know that initial weight. Very important number to have. So what we're going to do is we are going to take us one filter out of the box with our tweezers, and we're going to lay it inside the balance. And once that balance stops recording and gets to the weight, we're going to record that number. Very important part of this is on your filter you have a wrinkle side and a non-wrinkle side. It's a lot flatter. It's kind of hard to see on camera, but you always want to have that wrinkle side up. Know that. Potential test question. So we are going to just slide that in the balance. We're going to close all the doors and we're going to back up. You don't want a lot of vibrations. You don't want to be shaken. Talk about a few other things we're going to need that you see behind me here. We have our lab oven and our muffle furnace. Those two pieces of equipment, very essential for this test. They're very essential for the mixed liquor test as well as the mixed liquor volatile suspended solids test. Anytime you are testing for volatiles, whether it's your solids or your mixed liquor or whatever it may be, you have to have that muffle furnace, and we're going to explain why here in a second. But your lab oven, you're not actually cooking in that oven. The lab oven is meant to dry out the sample because the weight of the sample is going to be heavily increased when wet, right? So the lab oven's purpose is to dry out the sample. For this test, you want to leave that sample in the oven for 1 hour. You can leave it in longer if you do, but minimum 1 hour so that the sample totally dries. The lab oven, very important for your exam to know that your lab oven has to be set between 103 degrees Celsius and 105 degrees Celsius. That is the range at which your lab oven is supposed to stay set at for the entire hour that your sample is in there. So when you open the door, you're going to notice a temperature drop. It's always a good thing. I like to add another 30 minutes or make sure it actually rises back up to that temperature range, and that I'm not just pulling the sample out too prematurely. You want to give that sample time to dry. After it leaves the lab oven, it's going to come right here to the desiccator. The desiccator is another very important piece of equipment. It allows your samples to cool in a moisture-free environment, and that's what you want. You don't want to just set it out and allow moisture to latch back on, because that's going to give you an inaccurate result. So putting it in the desiccator for 15 minutes after it leaves the oven before it's weighed is a very important part of it, and you will see that potentially on your exam, especially your lab analyst exam. Once it is cooled in the desiccator and then you have re-weighed your sample, you now have the numbers you need in order to solve for your mixed liquor. We'll get to that later on in the video. Next, after you've weighed that sample, if you are going to be testing for the MLVSS, you then have to take it out of the analytical balance. You're going to be placing it in the muffle furnace. The muffle furnace is used in the wastewater world to cook off the solids. So it is set at 550 degrees Celsius. That's another exam question you're very liable to see. Having it set at that temperature is going to cook off anything organic on that filter. You simply place it in there and leave it in there for 15 minutes. You can leave it in there longer, but 15 minutes at 550 degrees Celsius in the muffle furnace, that's what you need to remember for the exam, and that's how long you have to leave it in there for it to actually do its job and cook off anything volatile. So once that 15 minutes is up, you can then remove it from the furnace, and you want to put it back in your desiccator. Once it's in the desiccator again for another 15 minutes, allowing it to cool in a moisture-free environment, you can then place it back in your analytical balance and have that weight. That weight is actually going to equal your ash weight. And with that number, along with the numbers you got for your MLSS, you can then solve for your volatile range and know your MLVSS. All of those steps we're going to show you here real shortly, but just wanted to kind of go over it in general beforehand, and now you'll get to actually watch us do the physical process before we take you over to the whiteboard and solve for both the mixed liquor and the mixed liquor volatiles. So let's get into it. Back over here at our vacuum pump and our funnel, we have our sample. We have weighed our funnel right here, or excuse me, we have weighed our filter here, so we know that initial weight. It's a very important part of the test before you get started. So next, let's go ahead and pour up our sample before we seat our filter. So if you've seen our glassware video, you know that it's very important to pour this at a certain angle so that you can read the meniscus. You can see that bubble on the line you want. For this test, we are going to pour up 50 mils in this graduated cylinder. But as you can see, it's actually settled out, our sample has. And that would be a very big misrepresentation of our mixed liquor if we did not actually shake this back up. So we're going to gently mix this back up. And you don't want to worry so much about flock shear in this instance. We are actually going to be measuring the weight of the sample. So the better it is mixed and the closer it is to how it was when you sampled it is going to be important. Whereas if you were doing a microscopic analysis, you wouldn't want to shear your flock and have stuff just messed up everywhere. But for this, it doesn't really matter. So we're going to mix it up pretty good. I mean, I'm not just violently shaking it. Give it a little stir. That's good enough there. Now we're going to pour up into our graduated cylinder that 50 mils. I've got it at eye level or a 90-degree angle so that I can see my bubble or meniscus. And there we go. We've got it dead on 50. And now we are ready to seat our filter. When I say seat the filter here, we're going to lay it on top of our funnel. And then I'm going to use my DI water bottle. I'm actually going to gently squirt some water right there onto the funnel, and then I'm going to use the bottle itself to actually seat the filter down inside that funnel. So we'll give you a top-down view of that as we do it, but I'm going to gently just kind of press those edges. It's very important that you're gentle at this point. You don't want to tear your filter, and then you're going to have solids pouring out through there going into the flask, and that's not going to be an accurate reading. So now that we have that seated, we have this ready, we're ready to pour. Now we have our sample poured up into our graduated cylinder, so let's pour it over our filter here. And the biggest thing to remember is not to flood your filter. You don't want to just fill up this whole funnel and have stuff going everywhere. Keep it contained on the filter, pour it as slow as needed. I really don't have to worry about that with this small of a sample. But next is very important that you rinse this out 3 times and you get all the solids that may be on the sidewalls there. And then I'm going to pour it right back over onto my sample. We're going to do that 3 times. Test question. Again, while I'm doing this, I'm not just dousing it with water. I'm pouring it slow. I don't want to overrun that filter and cause solids to pour over it, because then that's not going to be an accurate representation. Alright, now that we have finished drying off and the dripping has stopped, I'm going to try to pull it off so you can hear that pop. And there we go. Hopefully the microphone picks that up. But now we have our sample. It has been run through the funnel. It is all on the filter. We're going to go over to our lab oven and place it in the oven for exactly 1 hour, maybe a little longer, maybe not exactly, but at the minimum of an hour, so that it has time to dry before taking it out and putting it in our desiccator. We'll be back once we get done with that. Alright, Turd Nerds, it has been just over an hour. Our sample should be done drying. We're going to pull it out of our laboratory oven, and then we're going to place it in our desiccator for the 15 minutes. We're going to let it cool in that moisture-free environment before we put it back on the balance to get that dried weight. So let's open up the door and grab it out of there. Oh yeah, nice and dry, looking crispy. We're gonna set that down, close our oven, and we're gonna gently set it in our desiccator. Alright, we're gonna let that chill for about 15 minutes before we throw it on the balance there. We'll be back. I had to put on the lab coat threads. It just didn't feel as official. I'm sorry that I didn't take the time to do that when we actually pulled it out of the oven. So here we are. It's been 15 minutes. We've let it cool in that moisture-free environment. And let's take a close-up look before we actually put it on the scale. Do my best here. It looks like old crusty potato chip, old poop chip. You want to check out the poop chip? Take you a bite. Don't eat it, that'd be gross. That's our dried sample from our mixed liquor. So we are going to set that in our analytical balance. And while that number gets back into frame, while that number is cooking right there, we're going to give that a second, let it simmer down and get the actual result. All we've done so far is we've run our actual mixed liquor test. We collected our sample, poured it through the funnel, 50 mils. That's going to come into play whenever we're running our math for this. Next, after we got it all on there, we then put it in our oven. Your oven needs to be set for 103 degrees Celsius to 105 degrees Celsius in your laboratory. That's what they're going to look for if the EPD or whoever your agency is comes in for an inspection. They're going to want to see thermometers. They're going to see that you check that out, because that is what you need to have it set at per the standard methods method. You have your weight of your initial filter with no sample on it, and now we are weighing our filter after it has been through the drying process of the dry sample on there. So with these two measurements, we can now go over to the board and run our math, and we'll know what our mixed liquor is. But before we start that, first thing we want to do is remove this from the balance, and we want to put it inside our muffle furnace. 550 degrees Celsius for 15 minutes. It is going to burn off any organics that are left on that sample. And we will then require that ash weight after it's cooled in the desiccator for us to then be able to solve for the amount of organics that we actually have in the system. So let's do that now. We're going to remove it from the balance and go throw it in the oven. Excuse me, the furnace. Let's go. Sure you don't want a dookie chip? They're good. All right, and we're gonna drop it in there. Yes, it is hot when you open the door. So, I don't know if you can see that on camera, but it actually dropped in temperature. It's starting to gain right back up to that 550. It's gonna stabilize out, and we're gonna let it sit in there for 15 minutes. All right, Turd Nerds, here we are over here at the whiteboard. We are gonna use the numbers that we just got from our mixed liquor test to solve and be able to know what our mixed liquor actually is out in the basin. Yes, I've already solved it. It's on the sticky note. It's easier for me to show you and write it on the board and explain it. So, our initial weight of our filter, just of the filter before the test, was a 0.4223. We're going to say that's our initial weight, okay? Next, we have our final weight, which is the weight of the filter plus the dried sample on it, and that was a 0.6844. So to solve and start that process to find our mixed liquor, we want to subtract the initial weight of the filter from the final weight of the filter plus the dried residue. So when you do that in your calculator, do it with me here, you have a 0.6844 minus 0.4223 equals a 0.2621. Now, if you remember, we used 50 mils of your sample. That's where this 50 mils is going to come into play. So, with this answer here, we now have to divide that by the 50 mils because this is still in grams from the scale. So if we divide by 50 mils, that's going to get it into milligrams per liter, which is what we are then can use that to convert it into what we need it to. So to get this into milligrams per liter, we're going to divide this number, this small decimal, by 50, and when we do that, divide by 50, we're going to have a 0.005242. Now this is a very small number right here, and if you've seen our MGD video, you understand that scale of the MGD. If it's a very large number, we have to scale it down by division, and if you're starting with a very small number, such as this decimal, you have to multiply it up, multiply it by 1,000,000 to get it into that MGD form. So we are going to now multiply this by 1,000,000. And that's going to give us 5,242 Once you have multiplied it by 1,000,000, it gets you into 5,242 milligrams per liter. And that is what your mixed liquor concentration is going to be currently in the basin off of that one sample. This number is going to be able to move, and the way you move that number as an operator, let's say I wanted to keep my mixed liquor at a 4,500. Well, if this is what my mixed liquor number is, I now have to waste, because this is telling me the amount of solids in my mixed liquor is this high. So I need to waste more in order to lower this number and keep it within the range that I want to keep it in. But your mixed liquor, suspended solids, equals 5,242 milligrams per liter. It's been 15 minutes, a little bit more. We're going to take it out and let it cool in our desiccator. So Let's go. You want to see the difference between just dried solids and actually cooked solids that have been ignited in the furnace. A lot lighter brown, cooked off all the organics. We're going to let that cool in a moisture-free environment, again, for 15 minutes. Then we'll throw it back on the balance and crunch our numbers. We're going to remove the sample from the desiccator. It's out of the furnace, and we're going to set it back in the balance and let it balance, do its thing. As soon as we get this ash weight measurement, we will be able to then go over to the whiteboard and solve for our MLVSS, mixed liquor volatile suspended solids. Another very good thing to keep track of regarding process control. You actually can use that in other formulas to find F to M, and always something good to know about your bugs. Again, for us, we actually run our plant off of that mixed liquor number and off those solids. That's how we keep up with when we need to waste more or waste less. So having both of these numbers, the volatile number and the mixed liquor number, is very important for us in our process control here. So let's record our weight. And we're gonna head over to the whiteboard and solve for the volatiles. All right, Turd Nerds, we have now acquired all of our numbers. We've already solved for our mixed liquor, so we know that our mixed liquor concentration is going to be that 5,242 milligrams per liter. That is our mixed liquor. Now, in order to solve for the volatile content, I've written in here our ash weight. This is our initial filter with no sample, our dried filter and sample, and now our filter and sample after ignition. So everything that was actually volatile or organic was cooked off in that ignition process inside your muffle furnace. Alright, so now in order to find our mixed liquors volatiles, we want to subtract our ash weight from our final weight of the dried solid. So whenever we subtract our ash weight from our final, we are left with a 0.1773. Now we still have to remember the mils we used of sample, which was 50, so we need to divide this number by 50, and when we do that, we are left with 0.003546. We have to scale this number up, so let's multiply it by a million. And when you multiply it by a million, you're left with a 3,546. So that is actually your mixed liquor volatile suspended solids. So both the numbers that we have are very important, and they're very good numbers to keep up with regarding your process control. Now, if you wanted to go a step further and actually know the percent volatiles of your actual sample, know how much percent of the sample was actually alive, organic, or doing the actual job that you needed to do out there, you simply divide your mixed liquor by your volatiles, and when you do divide that, you get a 0.676. That's going to leave you with a very long number right there on the screen. You multiply that number by 100, and it is going to give you 67.6. So I could say that my percent volatiles are at 68%. And there you have it. That's how you run a mixed liquor. That's how you find your volatile content of that sample, and how you also find your percent volatile of that sample. Three very important numbers to be able to know how to find and use and be efficient for you at your plant and for your process. And not only that, it's actually very good and beneficial for you to understand how to solve and find all three of those regarding exam preparation and knowing how to do that on an exam. But here at this facility, we actually go off of these same numbers Every week, sometimes multiple times a week, we run these same tests so that we as operators are well informed of what's going on outside in our process, and that's how we are actually keeping up with our bugs and being good bug farmers, right? So if you like today's video, make sure you give it a thumbs up, subscribe to our channel, more content just like this coming out, and we'll see you soon. Turd Nerd out.